Hello and welcome back to our Go From Scratch series. I'm Daniel and today we're going to be talking about pointers. So as always, let's create a new file. Let's call this one pointers.go and we'll start with our regular template. Okay, so we've got our format package imported and we're just here in our main function. So let's take a look at regular variables. We've done this in a previous episode. So I'm assuming that you are familiar with variables in Go. We can use the colon equals just to assign an age to this variable. So we're going to say this variable here is an integer and let's just assign 30 to it. Let's take a look at what would happen if we create a function here to modify this age. So let's just call it change age. And we'll take in an integer, which will be the age that we pass in. And then let's print out the age at the time that it's passed in. So change age passed in. And we'll just pass in that A there. And then we'll modify that. So we'll say A equals 35 and then we'll print again what happens after. So change age A updated and pass that in again just so that we can see that it definitely gets updated. I mean, obviously this is going to update it, so yeah, this A is going to go from 30 here when it's passed in to 35. But then let's see what happens here within that function. So we can print out age first of all. So let's just add some text to make it easier to see. So age variable before function. Then we'll call the function, so change age, we'll pass in age, and then we'll again age variable after function. Okay, so we have this variable that we've set here, so age is 30. We're going to print it out here. Then we're going to pass it into this function here, this change age function. From here, we'll print it out at the point that it gets passed in. We'll update it. So we'll update A to 35 and then we'll print that out. And then here we'll print out the age variable again. Excuse the typo, after the function. And let's see what happens. Go run, what did we call this? Pointers.go. Okay, so age variable before the function is 30, as we'd expect, right? So we set it to 30 here. Change age passed in, so we pass it to this function here. That variable is getting passed in, and then here we print out the value. Then we change A to 35, and then we print that out. So change age A updated 35. But then when we get back here and we print out the value of age again, it hasn't updated at all. So it's still this 30 value here. And the reason for that is we are not actually passing through the actual variable here, we're passing through a copy of it. So when it gets to this point here, this A is actually just a copy of age. It's not the same variable that we have here. And we can see that by looking at the address. So let's add another print statement in here. So format print line, and we can get the address of a variable by putting the ampersand in front of it. So if we do ampersand age, we can get the address of this variable here. So let me just put some text in front here just to make it a little bit clearer. So address of age. And then let's take a look at the address of A. So format print line address of A. Okay, and if we run that, okay, so we run that and we can see that here we have the address of age. So this is where this variable is in memory. And then here is the address of A. So you can see they are quite similar up until this this last section here. So this is different. So we can see that it is in a slightly different section of memory. So this and this are not the same. So they're two different locations. Now that might seem kind of obvious, and you can get around that by, instead of trying to change the variable here, we have a return in this function. So this function will return the new age, and then here within this main function, we, instead of just calling the function, we'll update this variable here. We'll say age equals, and then the change age, where the value will be returned. But another powerful thing we can do is make use of pointers, and that will allow us to change the value of a variable within a function like this, because instead of passing through a copy of the variable, instead we pass through the address of the variable. So then this function will know, oh, okay, this is where it is. I can update it straight away. So let's see an example of that. Let's just create it now. So let's call it func change age pointer. And in this case, what we're going to want is a pointer to an integer. So we don't want an integer to be passed in. So we don't want a copy of age to be made and passed in as an integer. Instead, we want the address. We want this address of where that variable is. And then in here, we can make a change to that. So let's just say A equals 35. So we'll try and update it the same way. Now, one thing here that we have to be careful of is we're getting an address here now. So we can't change the address to 35 because the address looks like this, right? The address is this hex location of where it is in memory. So we can't change it to 35. Instead, we need to say follow to where that location is and then update that in that portion of memory there, update it with this integer value. So we do that by, again, using the same sort of syntax. This is where it might be a little bit confusing with pointers, having this asterisk, this star before either a type or before a variable. But when we have it before the variable here, this is where we are saying follow this address and then get to the actual variable that's in there, get to the actual value that's in there. So this is called dereferencing. Now, we've done that here. So we've updated it to 35. That should be all that we need to do. So let's, in our main function here, make a call to that function. So change age pointer, and we'll pass in the address of age. So now let's print it out again. So format print line and age variable after pointer, let's just say PTR function. Right, and we'll pass in age again. So let's just call this one, just to make it very, very clear, let's just make that one say reg function for the regular function, this one here, and then PTR for this function here. Now, I'm just going to clean up some of these print statements so that we can kind of see this a bit clearer without needing to to see all of those kind of debugging steps along the way. So we can, yeah, I think we'll just keep these. So we'll still print out the address because that's kind of interesting. We'll show the age variable before function. So this is when we first created it. Then we'll call that first function there. We'll print the age variable after that. So we already know that doesn't change. And then we'll call the one with the pointer where we've passed in the address, and then we'll print out what happens after that. So I'll just save this here, clear the terminal. Let's run that. Okay, and I'm sure you already guessed this is what's going to happen, but let's run through it so we can see it in action. So here we are, we're creating this variable and we're printing out the address of it. So that's that location there in memory. It's cleared away now, but I think that's changed again. So something to keep in mind that's going to change all the time. And the first time we print it out is the variable that we gave it, right? So before the function, it's exactly what we told it to be. Then we run this function here. Like we saw, this doesn't actually get to the same variable, so it doesn't change. And here it's 30, even though it's been updated to 35 in here. And then when we use our function where we're passing in the pointer and we're giving it the address of the variable, and then we're dereferencing our pointer and updating the value to 35, then we can see, okay, now in the main function, that variable has been updated. So that's kind of a quick intro into how pointers work and a little bit of a glimpse as to how they can be powerful. A reason why you would want to do this, I mean, here it's just a small integer, right? So it doesn't really matter, but sometimes you might be copying large amounts of data and you don't really want to make a copy each time. So if you're doing a lot of calls, if you're in a loop, especially if you're dealing with recursion, you might not want to be making a copy of the variable every single time you want to work with it. So in this case, we can just point to the address of it and then work with the one variable, the one location, the one place in memory. So the size of a pointer in Go on a 64-bit system will be 8 bytes, whereas a variable could be much, much more than that. Say you've got a string that's many, many bytes or kilobytes or megabytes even. So if you're only working with a pointer, it's going to save you a lot of memory. So whether or not that's important for you and your program is totally up to you. It's a design decision, and not every program is going to need pointers all of the time. Sometimes this is a bad idea. Sometimes you don't want to do this because it's going to be surprising. If you've got functions that are changing variables and there's no obvious visibility over that, that's going to be a problem. So this is a design decision. Use it with caution and think about the implications of it, but it's important to know that this exists and it's here and it's going to be part of your toolkit. So let's take a look at what we did in the last episode. So in the last episode, we looked at structs and we created a person struct. So we had this person here. Struct. So with this person struct, we gave them a name, which was a string, and an age, which was an integer. Redeclared in block. Oh, okay, yeah. So the other file, because we're using this package main, the other file where this is defined already is going to have it there. So that's why my my editor is saying, hey, this already exists, but we're only going to be running this one specific file, so that's not going to cause an issue. So we've got this person struct here, and this is if you haven't seen that episode, this is just a sort of custom variable where we can create an object based on custom set of fields. Right, so now that we have this person here, let's create a method for them. So here we can do it the same way as creating a function, but instead we pass in, or what we're going to pass in is a pointer to that person. So this should start to make a little bit of sense now after we've just been through all of this. So here we're passing in a pointer to the person, which means we're not passing through a copy of this variable here. We're passing through the address of where this exists. Now this is just the definition of it. We haven't created a person yet, so we'll do that in the main function. But just kind of sowing the seeds of looking at what's going to happen there. Then we're going to have the have birthday method. So you have a birthday, you're a year older, right? So we'll do that. So obviously we're getting the person pointer passed in. So here we can make use of that age field here, and we'll increment that. Okay, so we're all set up. We've got the person struct, we've got the have birthday method. Now let's actually do it. So I'll put it at the bottom here so that we'll keep all this here, but then I'll put it at the bottom so that we can see it after we've run it. So let's create a person. So again, let's just call the person Daniel, and they will be a person. And let's say the name Daniel, and the age is 30. Right, so we have this created. Let's just print them first of all. So we'll just print out sorry, I forgot the formats, print line Daniel. Okay, so let's just do that now. Okay, let's see it in action. So we've got our person here, Daniel 30, and now let's call this have birthday method. So Daniel have birthday, have birthday. And then let's print again, format, print line, Daniel. Okay, and let's see this in action. I'll just clear the terminal. And there we go. So now we have this age here being updated. So this can start to sow a few seeds of how this can be more powerful. Here, we're dealing with a bit more of a complex object, right? Like this isn't just an integer. This is a whole person that we're dealing with here. So you might be doing more than just incrementing their age. You know, you might be sending a birthday card to them. You might be updating a whole bunch of things. You might have a photo included in this person structure. And if you were to make a copy of that every time that you wanted to deal with them, every time, you know, you have a birthday, pass in who that person is, and you're creating a lot of unnecessary, you're using up a lot of space unnecessarily, when you could just deal with the pointer and change those variables directly. So again, design decision. You're not going to want to do this every time. There are times when you absolutely won't want to do this. It does add complexity, so be careful. But good to know what's going on here. Definitely important to know if you're going to be writing Go code. Okay, now before we wrap up, there is also something I should make clear here. Notice how in the method for the struct, we don't dereference the pointer. When I added the function here, the change age pointer, we had this asterisk in front of the variable, and that is to dereference the pointer here. In Go, when you're working with a struct, it will actually dereference it for you. So you don't need to add that asterisk in there. Go will do it for you. This is something just to make it a little bit more easier to work with. It's something that's built into the Go language, specifically around structs. So keep that in mind. If you're used to working with structs and you're not dereferencing the pointer here, and then you try to create a regular function and it's not working, that's why. So bit of a different case here. in a struct, Go will dereference the pointer on the field here for you. So I hope this has been useful. I hope you're enjoying the series. If you are, please subscribe, like, give me a comment. I would love to hear from you. Otherwise, see you in the next episode.